Hello everyone, welcome back to another video. My name is Dylan and I've got a different kind of video today. Still linked to the sats, but you can probably see in your screen around here, I'm going to highlight it. This is from 2004. 2004. Now what's special about that year? Well, it was 20 years ago. The world was quite different back then. And I was 10 years old. This is the exact sats paper that I took when I was in year 6. So we're going to take a look to see how it's different to the ones that we've been taking these days and what's changed over 20 years and what stayed the same. And there is a really tricky question in here that I can't wait to show you. It's near the end, so stick around for it. But the first thing I notice is this. Look at that box. Calculator not allowed. Well, of course, we're not allowed calculators in sats papers. But why would that be written on the front? Well, this is paper 1. There was a paper 2. What do you think you might have been allowed? Well, if this video gets enough likes and comments and we get enough subscribers, I will do paper 2 as well. So let me know down below if you want to see the calculator paper. Yep, they used to let calculators in the sats. But without further ado, let's dive straight in and let's see what kind of questions there were in the sats from 20 years ago. 10-year-old me did this exact paper. Write in the missing numbers. Something plus 85 is 200. Well, that's obviously quite straightforward. 115 would be the missing part. You can check that by adding those numbers together. 4 multiplied by what is 120? Well, look at it as like 12. 4 times 3 is 12, but it's 120, which is 10 times bigger. So we need to write down 30. 120 take away 51. Again, I would split this up into take away 50 and then take away 1. 120 take away 50 is 70. Take away 1 leaves us with 69. Quite straightforward questions. I would argue, I'd say, okay, not much has changed. If that come up these days, I wouldn't be too shocked. Here's a square. What fraction of the square is shaded? Very simple. 2 parts shaded, so the numerator is going to be 2. Out of how many parts altogether? It's not 6. 1, 2, 3, 4, 5, 6, because there are 6 white pieces. You have to count all of the pieces for denominator, including the shaded ones. So there are 8 pieces altogether. 2 eighths is an answer that will give you 1 mark. You could also have written 1/4, as that's an equivalent fraction. Let's take a look at this one then, a money question. Money always comes up, so that's not changed. The only thing that has changed though, no way am I getting a cheese sandwich for £1.45 these days. More like £145, right? So those prices have shot up, very different back then. These are the prices of sandwiches, drinks and fruit. Shireen buys a tuna sandwich, milk and a pear. How much does she pay? Simple question where we've just got to add up 3 amounts, but classic again, some of it's given in pounds, some of it is given in pence. Let's add these 2 up together in pence first. 55 plus 20 is 75 pence. Notice there's no space for working out here. A lot of this was expected to be done mentally back then. I remember my teacher saying to me, if you can do it in your head, do it in your head, which is fine. Mental maths is important, but you could also jot some things down if you weren't too sure. Then we've just got to add the price of tuna, which is £1.70 or 170p. Make sure you just keep the units the same. 5 in the ones, 14 in the tens, exchange over. We have 245 pence, which is an acceptable answer, but I want to write it as pounds. So I'm going to write £2, decimal, and 45 pence. And there is a second part to this question. Mike has 80 pence to spend on fruit and drink. What 2 things could he buy for exactly 80 pence? So we need 1 thing from this column and 1 thing from this column. Work systematically. Milk is 55p. That leaves us with 25p to get to 80 pence, which means melon works. So we could put milk and melon. So we can write down milk here. We can write down melon there, and we'd get the mark. There is another option though, with juice being 65p and an apple 15p. Guys, I wish that these were the prices these days. My goodness, much cheaper than we get these days. So there are 2 options there. Both would get you a mark. Measure accurately the length of the diagonal of this square. Now, I can't do this because I don't have a ruler, but I did do a whole lesson on how to measure accurately. You need to make sure your ruler is parallel to the line. That is the worst ruler you've ever seen. Your ruler would be actually straight. And you also need to make sure that where you measure from, that says 0 on the ruler. Quite often on a ruler, guys, at the end, it would look like this. 0 would start at this line. You need to measure from 0, okay? Don't measure from the end of the ruler. You must measure from where it says 0. That way, you know, you're going to get a nice, accurate measurement. So I don't know how long this is because it depends on the paper. But if you're stuck on how to measure accurately, go and watch my measurement video. It's one of my recent videos that I did. Question 5. Use each number card once to make the answer to each calculation an even number. Even numbers end in 0, 2, 4, 6, and 8. Let's see what we can do. 5 multiplied by something. Well, I can only use each card once. So let's take a look. If there's more than one option, I'm not going to write a final answer yet. That's one of the tips I did on the previous video. 5 times 3 is 15. That's not even. 5 times 4 is 20. That is even. 5 times 5 is 25. That is not even. Only 4 works. Get rid of 4, just 3 and 5 left. 12 divided by what? Well, 5 doesn't even go into 12 exactly, so it can't be 5. It must be 3. And yes, I can check. That gives me an even number, which is 4. Even at the top, which is 20. Now, that only leaves me with 5, so I'm going to whack it straight in and hope it works. I can prove it because 9 plus 5 is 14. Ends in a 0, ends in a 4, ends in a 4. They're all even. 2 marks for this. Seems quite generous, right? Next question. Are you guys seeing this? Are you guys... I've got to zoom in. That is Hayden. That is Hayden with hair. What is he doing in a SATs paper from 20 years ago? I told you he was old. That is Hayden if I've ever seen him. Guys, get a picture of Hayden. I know he doesn't have any hair now. Imagine him with hair. This is him. He is him. Can we get a comment, please, down below saying, Hayden in the SATs? He's going to be like, what are you on about? And that'll force him to watch this video. My goodness, I'm zooming back out. Okay. That has shocked me. That is Hayden right there. Alan. It's not Alan. We know it's Hayden. Hayden has 45 beans. He plants 3 beans in each of his pots. How many pots does he need? Quite simple. We have 45. We're going to share them equally. Share 3 beans into each pot, equal amounts each time. So we do 45 divided by 3. Goes once with 1 left over. 3's into 15. Go 5 times. We need 15 pots. You can check this by doing the inverse. 15 times 3. You end up back at 45. Hayden, nice to see you, mate, but we're moving on. Leila, whoever it is, puts 4 seeds into each of her pots. She uses 6 pots and has 1 seed left over. How many seeds did she start with? Well, let's draw those 6 pots in. These aren't very detailed pots. They're just circles. But we know there's 4 seeds in each pot. So 4 multiplied by 6. That gets us to 24 seeds. But remember, she had 1 seed left over. We must add that one on, which means she had 25 seeds to start with. Question 7. Here are 5 shapes on a square grid. Pretty straightforward, right? For 20 years ago, maths hasn't changed that much. Write the letters of 2 shapes which have a line of symmetry. Okay, well, straight away, A has a diagonal line of symmetry. Diagonal lines are the hardest to spot. A line of symmetry is where if we fold down that line, the corners would match up perfectly, the edges would match up perfectly, there'd be no overlap. A works beautifully. There's one more, because look, the question said 2 shapes. B. No, look, we drew a line down the middle. We'd need a shape that looks a bit like this. That just doesn't exist. And the line across here, no, it wouldn't line up exactly. This just doesn't match up. Same for C, doesn't match up. D is interesting. D has symmetry, but it doesn't have a line of symmetry. We did a short recently about lines of symmetry, and loads of people commented saying, oh, well, actually, there are more lines of symmetry in that shape because actually there's a thing called rotational symmetry. I know. This has rotational symmetry. If you rotated it 180 degrees, it would end up in exactly the same place. That's called rotational symmetry. But it doesn't say that, guys. Neither did a question on my short, by the way. Not that I'm bitter about it or anything. It says line of symmetry. You cannot draw a line for rotational symmetry. They are different things. D has no lines of symmetry. It has rotational symmetry, but that is not a line, right? God, glad I've cleared that up. And the last one is E. This does have a line of symmetry. Again, it's diagonal. Hopefully you can see that. Turn your head. You can see if you folded it, it would go perfectly. So the answer is A and E. And now we know the difference between lines of symmetry and rotational symmetry. Calculate 13.6, take away 2.8. 13.6, 2.8. This is just an arithmetic question, isn't it? 6 take away 8 we cannot do. Well, we can. We're going to minus numbers, but I don't want to do that. 16 take away 8 is 8. Put the decimal in. 2 take away 2 is 0. And we have 1. This is 10.8. So back in the day, 20 years ago, I did not do an arithmetic test. There were just 2 reasoning papers and what we call a mental maths test, which was kind of like arithmetic, but more in your head. So these kind of questions found their way onto these reasoning papers, which is quite interesting. Question 9, Abby takes the temperature outside. I'm going to just make it a bit smaller so we can fit more on the page. Abby takes the temperature outside at midday on the first day of each month. The graph shows January to December. How many months on the graph show a temperature between 10 and 20? So we need to go to the y-axis and find 10, which is here. And if we draw a line right across, anything below will not count. And now we need to go to 20, draw a line across. Again, anything above will not count. It needs to be between these lines. That gives us March, April, May, July, and October. 5 months have a temperature between 10 and 20. Find the difference in temperature shown in the graph between July and August. Well, let's now go to July. this temperature here, it's just above halfway. So halfway between 15 and 20 would be 17.5. We're just above that. So that means in July, it's 18. In August, we're on the line, which is lovely for us to read off. It's 25. What's the difference between 25 and 18? It's 7 degrees. Again, look at this paper, guys. So far, I've not had any squared bits to do my working out. It's just trusting that you'll do it in the blank, and it's not forcing you to do it. And it's thinking you might do some mental strategies too. A shop sells 3 types of sunglasses. What is the difference of price between the most expensive and the least? Well, this is the most, £5.85. This is the least, £2.99. And I'm going to show you a method here, because you could just do column method, £5.85, take away £2.99. You could do that with exchanging. However, when a number's really close to a nice round number, so £2.99 is really close to £3, you can take off £3. That gets me £2.85. But £3 was 1 pence too much to take off. So I went 1 pence too low in my calculations. So that means all I have to do at the end is add 1p back on, and I get £2.86 as my answer. A nice mental strategy there. Something, again, we've kind of lost over the years. Back in the day when I was in school, 20 years ago doing this paper, I probably would have done that mentally. The shop also sells sun hats at £3.29 each. He buys £4.69 sunglasses. How much change from £10? They've been asking this question for 20 years. How much change from a tenner or a fiver? It's so common. Okay, it's almost bound to come up. It's been coming up for over 20 years. Look at this. So firstly, let's figure out how much he actually spent. £4.69 plus the sun hat, which we know is £3.29. So again, just use column method, especially where it says show your working, because you might get a mark. Very important. 9 plus 9 is 18. 6 plus 2 plus 1 is 9. 4 plus 3 is 7. And now I'm going to do my counting on. Okay, that's how I can work out change. Go from the lowest amount. We're going to head up to £10 with decimal in the middle. How do I do that? Well, 2p gets me up to £8, and then £2 gets me up to £10. So the difference is £2 and 2p. Make it really clear, guys. Look, I'm with the mouse of destiny again. Okay, it's hard for me to write, but this is £2 and 2 pence. Hopefully that makes sense. Hopefully 10-year-old me was on the right track as well. Film starts at 6:45. It lasts for 2 hours and 35 minutes. When will it finish? This is such a bog standard time question. If you struggle with time, I want you to know we've done loads of videos on it. Go back through our channel, find the time video. We do lots of duration problems like this. 2 hours, 35 minutes. We'll jump forward 2 hours, gets us to 8:45. And we've still got 35 minutes to go. Well, jump forward 15 minutes to get to the next hour. That gets us to 9. And if we've used 15 minutes out of these 35, what's left? Well, hopefully you can tell that's just 20 minutes left. So 20 minutes after 9 is 9:20 p.m. Guys, you need to do jumping forward. Using a timeline for this is the best way. Okay, I promise you. For example here, if you did 6:45 plus 2 hours 35, 5 plus 5 is 10, 4 plus 3 plus 1 is 8, and we get 8:80. Now that might confuse you. 8:80 is not a time. If you're really confident, you might know that there's 60 minutes in an hour, so it'll go to 9 with 20 left over. But the best way is to do the jumps forward, just like this. Question 12, here's a sorting diagram for numbers. This question is really interesting because there are literally like tens of answers. There's loads of answers we can write down. Write a number less than 100 in each space. A square number. Now a square number is the answer we get when we multiply the same number by itself. Okay, so we could get 1 is a square number, 4 is a square number, 9, etc. 3 times 3, 4 times 4, 5 times 5. I want an even square number, so 2 times 2 is 4. I want a not even square number, 3 times 3 is 9, so we've done the top half. I want not a square number that's even, cool, 6. We can't get 6 by multiplying a number by itself, but it is even. And not a square number that's not even, there's loads of them. Any prime number would work in this case apart from 2. So for example, 11, that is not even and it's not a prime number. Loads of answers to this. You could literally write this question down like 50 times in a row with different combinations and still get 2 marks. Again, 2 marks. Very nice, very kind. This is a drawing of a pentagonal prism. Tick the one shape that is a net for the pentagonal prism. It's very common to go tick. It's this one. 2 pentagons either side, nice rectangles in the middle, but it's not. Because look, 1, 2, 3, 4 rectangles. We need 5, guys, because there are 5 sides to a pentagon. 1, 2, 3, 4. This would be left without a side. We would not have this face on this net here. This one it can't be because the pentagons are on the same side. It is this one in the middle, because if you think about it, this pentagon has 1, 2, 3, 4, 5 rectangles coming off, and this would be the cap on the top. Imagine it folding over and perfectly fitting on top. It says tick one shape, so as soon as we know it's this one, we don't even need to check these ones. Don't waste time. So still 20 years ago, those methods of just don't waste time, move on, they were still really important. Question 14, times table grid. These are still coming up to this day. So clearly we need to know our times table still. 4 times what is 36? Well, if you know your times tables, this is so easy. 4 times what is 32? That's 8. 5 times what is 35? That's 7. 5 times what is 30? That is 6. Now, I did that without even looking at these answers. We can use them to check at the end. 8 times 6 is 48. Cool, that works. 9 times 7 is 63. Cool, that works. But we could have solved it just using our 5 times table and our 4 times table. Something to consider. This next question, I love it. I love this question. It's really good use of testing if you really know what perimeter is. Millie has some star-shaped tiles. Each edge of the tile is 5 centimeters long. She puts 2 tiles together. What's the perimeter of the new shape? Now, the trap here would be to think, okay, well, there are 10 sides to this star, and each side is 5. So that means that this is 50 centimeter perimeter. So if I have 2 of them, clearly the answer is 100. But it's not. And here's why. This bit right here. That is why, because we have some edges now, because of the overlap, that are inside the shape. And if we know anything about perimeter, it's that any edges inside the shape no longer count towards the perimeter of the shape. So the number one thing to do here is to count the edges. So how many do we have on show? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We know that each one of those lengths is 5. So we have 18 multiplied by 5. And a nice shortcut for multiplying by 5 is to multiply by 10 and then halve it. So 180 halved, that is a 90 centimeter perimeter. Look, less than 100 because we lost these 2 sides. A quick method would be 2 times 5 is 10. We lost 10 centimeters of perimeter. Take away 10 from 100. You would have also got to the right answer. Mr. Khan makes blackcurrant drink for a party. He pours blackcurrant squash into a jug. How much water must he add to make 500 ml? So we want to get to 500. So we're going to do 500 ml, which is what the total we want. We're going to take away something, and we need to be left with what's left in the jug. Well, what is left? We've got 100 and 200. What's each jump worth? Well, how many jumps are there? 1, 2, 3, 4, 5. So we need to do 100 divided by 5, which would tell us what each jump is worth. That is 20. So we have 100, 120, 140 ml of squash. So what's the difference between 140 all the way up to 500? The answer is 360 ml. You can check that by adding 300 with 140 and you will end up at 500. A nice difference question there, and checking our intervals. Okay, there are 5 jumps over 100 ml. So you do 100 divided by 5. Very, very, very common. Another arithmetic question. This would be in the arithmetic paper these days, but back when I was taking the SATs test, it was just in the middle of my questions. 6 sevens, you still need to know times tables. 42, put your decimal in. 1 times 7 is just 7, plus 4 is 11. 7 times 3 is 21, plus 1 is 22. We have 221.2. Here we go. Mary. Oh, look, it's Hayden's sister. Looks just like Hayden again. Must be his sister. Is the presenter of a weekly radio show. She plays 5 new songs for every 2 old songs. So that means across 7 songs, 5 are new, 2 are old. Last week, she played 15 new songs. Okay. How many songs did she play altogether? Well, we need to figure out how many old songs she played. So for every time we see 5, we play 2 old songs. So in 15, how many 5s is that? 5, 10, 15. So we multiplied that by 3. So for our ratio, we must do the same, which means she must have played 6 old songs. Now we simply combine these together. 15 new songs plus 6 old songs, that's 21 songs altogether. That'll get you 2 marks. Julie says, I added 3 odd numbers and my answer was 50. Explain why she cannot be correct. I'm going to show you a little something here. Okay, this is something I remember learning at school. Every single odd number you can ever think of is an even number plus 1. Now that works for any odd number you can think of. Tell me an odd number. 33? Cool. Well, 33 is the even number 32 plus 1. So when you add up 2 odd numbers together, what you're doing is you're adding up 2 of these even numbers plus 1. Okay, so what does that mean you'll always get? Well, 2 even numbers, they always add up to be an even number, plus 2, which, by the way, is an even number. So that means when you add up any 2 odd numbers, the answer is always even. So what happens if you add up 3 odd numbers? Well, we know 2 odd numbers Two odd numbers is always going to be even. Let's add another odd number, which we know is even, plus 1. Look what will always happen. Two evens make an even, and we'll still have that plus 1 left over, which means we have even plus 1, which is odd. Okay, that's a long way of proving that if you have three odds, it has to equal an odd. And you can explain that using the proof I've just given you. That's what you need to say. Three odds will always make an odd, because two odds make an even. If you add an odd number to an even number, you're going to end up with an odd number. That is proof that three odd numbers always end up with an odd answer. This comes up all the time too. Coordinates where there are no scales on the side and you need to use the shape to help you do it and the given coordinates. Here is a kite. Write the coordinates of point D. Now the cool thing about point D, we can work out the x coordinate straight away. We know what this is because we can just simply use point B. 5 across, 6 up. So that means that we went 5 along the corridor, which means that the x coordinate for D is 5 across. Now, what would the y coordinate be? What's this number here? Well, let's label what we know. B is 5 across, 6 up. So that means that we are 6 up for B. A is 3 across, 4 up, which means we're 4 across for A. And the cool thing about a kite is the difference between the middle point A up to B is the same as the middle point A down to D. So if that's a jump of 2, this must be a jump of 2. What's 2 less than 4? It's just 2. So to get to D, we go 5 across and we go 2 up. We've seen loads of questions like this from a few years ago to 20 years ago when I was 10 years old. So questions like this are really worth practicing because they still come up now. Even though we've changed the curriculum, they still come up these days. It's an important point to make. The curriculum changed about 10 years ago. So some of the stuff in this old paper we don't need to do anymore. For example, paper 2, if you want it, tell me down below and I'll do paper 2 with the calculator. We don't use calculator anymore in SATs in Key Stage 2. Order of operations. 900 divided by 45 times 4. You must do brackets first. 45 times 4 is 90 times 2, because I like to do doubling, and that leaves me with 180. So 45 times 4 is 180. How many 180s are there in 90? Cool trick when we divide. We can divide both sides by 10, and we end up with 90 divided by 8, and we end up with 5. There are 5 18s in 90. If you can't do 90 divided by 18, sorry, not 8, 90 divided by 18, you can do 90 divided by 6 divided by 3, because we can use factors. 6 and 3 make 18, so we can swap divide by 18 with divide by 6 by 3. Those two steps might be easier for you to do. The answer is 5, either way. Liam thinks of a number. This is the question. This is the question I was talking about earlier. It seems like a really innocent, nice inverse question, but it's actually much harder. He multiplies a number by 5, so he starts with a number. He multiplies it by 5. He subtracts 60. And his answer is the same number he started with. My goodness me. So what we need to work out here is that when we multiply by 5, we must actually increase it by 60. So whatever we multiply by 5, we have to increase by 60. Now here's the important thing. You might think, okay, well, 60 divided by 5 is 12. So I must start with 12, right? Okay, well, 12 times 5 is 60. Take away 60 is 0. So that does not work. Here's something really interesting. We're going to take 4 as an example. If I do 4 times 2, I end up with 8. Okay? 4 times 2 is 8. So when I multiply by 2, I actually added 4, which is one lot of 4. Let's do 4 times 3 now. 4 times 3 is 12. So when I multiplied by 3, I actually added 2 lots of 4, because I added 8. And if I do again, 4 multiplied by 4 is 16. I added 12, which is 3 lots of 4. So when we multiply by a number, say we multiply by 4, we're adding on 3 lots of that number because we already have 1 lot. So when I multiply by 5, I need to be adding on 60. So I need 4 lots of my number to be 60. And in that case, it would be 15. Now, if you don't believe me, let's try it. 15 is a number he starts with. Let's multiply that by 5. 15 times 5 is 75. Now let's take away 60. Yes, the answer is 15. This is an incredibly hard question. And the best way that you probably have to answer this, because this would be really hard to know and understand. When I was 10, remember, I probably got stuck on this question, is trial and improvement. So you put a number in and you just see if you were right or if you were wrong. That's another way to do it, okay? It's probably the way it wants you to do it using trial and improvement, because knowing this would be really tricky. So all you'd have to do in this case is plug in a number. If you put in 12, you'd know my number needs to be bigger, and then you keep having to try again. But look, this wastes so much time. It wastes so much time. This is a question that you should skip, and that's still the case today if you want a really tricky question. Question 23, here's part of a train timetable. How long does the first train to Edinburgh take to get to Inverness? Well, here's Edinburgh. Where's the first train? It's the 9:35, and it travels downwards to Inverness, which is 13:10. Again, another time question where we have to do jumps between two amounts of time. We've got 9:35 and 13:10. What's the difference between them? Well, let's jump forward as close as we can get here. Let's say we go to 13:35, would be too far away. So let's say we go to 12:35. So we know our answer is going to be 3 hours something, because that's a 3-hour jump. How do I get from 35 to 1? That's 25 minutes, gets me to 1300. And then I've got 10 more left over to get to 13:10. So I've got 3 hours, 25 and 10. That is 3 hours and 35 minutes. You have to put your units. It's really important. And that does work out exactly right. Ellen is at Glasgow station at 1:30 p.m. She wants to travel to Perth. She catches the next train. At what time will she arrive at Perth? A really common timetable question. So let's take a look. Ellen is at Glasgow at 1:30. So Glasgow at 1:30, 11:15, 13:15. She's there later than this. So the next train she could catch is this one. And the question asks, she travels to Perth. What time will she arrive at Perth? Well, let's follow this down to Perth. 15:15. That is the next time she could get there if she caught the next train, which is what it says she did. Just double check. Yeah, 15:15. She catches the next train. Okay, so classic use of how to do timetables there. I would argue one of the most useful things to understand in maths, because you're going to have to catch public transport in your life. So very, very, very useful in my opinion. 5% of 3,600, less useful really to be able to do without a calculator, but still really easy nonetheless, because 10%, we just divide by 10. So we know 10% of 3,600 is 360. 5% is half of 10. So we half 360 and we get £180. If you know your method, very easy question. Last question on the paper. I love this question. Guys, what I want you to do is tell me in the comments what the answer is. Thank you so much for your support lately. I love this one. Here's an equilateral triangle inside of a square. If the perimeter of the equilateral triangle is 48 centimeters, what is the perimeter of the square? You've got to work out each side, work out the square. Let me know in the comments down below. Guys, like this video, share, subscribe. We love having you guys along for the ride. And let me know in the comments as well what you want us to make videos of in the future, because we will do it. Catch you next time. Let me know the answer.